All across campus, you may stumble across the occasional grate in the ground, offering a brief, dark glimpse into the tangle of infrastructure beneath the university. There is, in fact, an extensive utility tunnel system running for miles beneath the campus. All these tunnels can be traced back to a central point, one of the most important buildings for students. The power plant at the UW has a humble exterior but houses a massive maze of pipes, wires, valves, meters, and gear. Mark Kirschenbaum, the Assistant Director of Campus Utilities, is largely responsible for making sure that the plant and tunnels run in tip-top shape. He was kind enough to show us around.
We are here primarily to provide heat to the campus in the form of steam. So we have big boilers, we burn natural gas, boil water, collect the steam, and we send it out to the campus through the tunnel system to be distributed to the buildings. And in the summer, we not only make steam, but we also make chilled water, about 42, 43 degree Fahrenheit water that we send to about 50 buildings that provide air conditioning.
We head off to see where heat is made in the belly of one of 5 metallic beasts, a giant boiler with a massive flame.
Okay, so this is boiler number 7. This is the newest boiler in the power plant, installed in 2000. And we're gonna go down to the next level and actually look inside this boiler so you can see the actual combustion process. But look at the boiler construction. There's thousands of water-filled tubes inside absorbing the heat of the flame. The flame's about 2,000 degrees Fahrenheit. By the time that gas leaves this boiler and goes to the stack, it's down to about 260 degrees Fahrenheit. It's absorbed all that energy, all that heat into the water to make the heating steam to keep the campus going.
Mark then took us out of the power plant to show us how heat is transferred to the rest of the university through the tunnel system referred to as lower campus.
Okay, so this is where we're going to enter the tunnel system. Earlier I talked about how the power plant produces utilities like steam and compressed air. Then we transport them through the tunnel system to provide service to the buildings. So this is one of our entrances. You can see the services running along the side of the tunnel, and we will just march our way through.
You're not going to see much moving, but if you can just envision in every pipe you happen to be looking at, there's motion. If this piping was clear, it'd be a massive movement everywhere. Water, steam, air, chemicals, all to support the university.
You've gone 10 feet, you've seen the entire tunnel. Well, you've gone 100 feet, and you pretty much really have seen how the tunnels are. Very quiet, kind of warm and muggy, as you have probably felt. And the only time it's not nice or comfortable is when there's a leak. And when there is a leak, it's very loud, very hot, and definitely an area to avoid. This is one of the reasons we really don't like students to be down here unescorted, because this is quite a large leak, very loud, very hot.
We stepped gingerly around the leak and continued on our way down the tunnel, up some stairs, and finally into light. We were glad for Mark's help on our journey, while Mark seemed satisfied to know that nobody was hurt. Between the dark, steam and gas leaks, the possibility of heat stroke, and very high voltage cables, the tunnel system takes an expert to safely navigate. Safety is of the largest concern, and a complex security and surveillance system is in place to ensure that nobody endangers themselves by trespassing. You may not be able to see the tunnels for yourself, but next time you walk around campus, try to feel the thrum of the system below you.